Hello everyone. I hope you are doing well. Welcome to the channel. Welcome back to CFD College. I'm Ashkan, and in this session we will continue our course on CFD Post, actually post processing or CFD results in CFD Post. This is the fifth session of this training course. This is a free training course, and you can use it to master CFD Post and to make some good, exports from your CFD simulations. As you know, in this channel, we usually talk about CFD, commercial software, especially ANSYS Fluent and other software related to that. So if you need these kinds of videos, if you like them, and if you find these videos useful for yourself, please subscribe to the channel, like the video, and share these videos with your friends. Let's jump to the uh, main part of this session. So far, we've covered these four sections. Introduction, how we talked about how we can display our geometry, how we can display some contour plots and isosurface and isoclips, and how we can use them. In this session, in this tutorial, I will going to teach you how you can create velocity vectors. Velocity vectors are useful in situations we want to show the fluid domain, show the flow domain, show the flow field in our domain. Uh, it's to show to have a good view and representation of the flow field. You have to modify the velocity vector to get a perfect view of that. So in this video, I will show you how you can do that in 2D and 3D domains. Let's start with two-dimensional domains. As you know, this is a flow passes this cylinder. So it was a two-dimensional CFD simulation. In two-dimensional cases, it's easy to create contour, velocity vector, streamline, and other plots and something else. However, it's a bit complicated in three-dimensional. So we start with 2D. To generate a velocity vector, you can click on this icon, which is velocity vector, or you can go to Insert tab and select vectors. So you can specify a name for it. The default name is okay for me. And after that, you can modify the view in this in this section. This is the details of your velocity vector. As you know, it has different tabs, uh, geometry and color, uh, symbol, render, and view. You know that the render and view tabs are almost everywhere in CFD Post. And I think the main tabs and the main details are included in geometry, color, and symbol tabs. So let's start with geometry. In this tab, you have to specify the location on which you want to see your flow field, your vectors. So in 2D simulation, we have only one choice, and that's why I told you it's easy. Either symmetry 1 or symmetry 2. You should choose one of them, and there is no difference between these two. So you have to choose one of them, and for example, let me choose symmetry one. And then you have to specify the sampling method. The default is vertex. You have other options: equally spaced, rectangular, grid, face center, free edge, and random. Then you have to, specify the reduction method. You can specify the maximum number of points or the reduction factor. You can use the reduction factor. So let's start with the default settings. Under the color tab, you can change the color of the vectors. Let me click on apply. The default coloring for the vectors are is velocity variable because it's the plot variable. You are plotting velocity vectors, so it's usual that you choose velocity for the uh, coloring variable. As you see here, we have a lot of vectors, and we almost can see nothing because the number of vectors are too much. There are too much of vectors here, and the length of these vectors, I think it's not good for this view and for this flow field. So you have to play with these settings that are available in these tabs. The sampling is on vertex. You can change it to equally spaced. Now you have to specify the number of points. For example, if I want to have 5,000 vectors, I can change it to equally spaced, and the number of points is 5,000. See, in this way, I will have 5,000 vectors in my domain, actually on symmetry 1. Uh, each of these methods, uh, you have to play with these types to get the best view uh, for your simulation, for your case. It's not, I can't tell you which one is the best because it depends on the case, on the domain. So you have to, I think, many times you have to test each of them and, try to get the best view. Equally spaced is good uh, mostly for flows inside, for example, pipes. Here, in this case, I have an external flow. So I have a cylinder here and the flow passes over it. So at regions far away from the cylinder, there is nothing special. So here we know that the flow direction is towards right, and there is no special, phenomena here. So I think equally spaced is not good for this case. Uh, Instead, we can use the vertex method. Let me click on apply. In vertex method, uh, you will have uh, a greater number of vectors where your mesh is fine. So in these sections, far away from the cylinder, the mesh is coarser than what I have near the cylinder. And as you can see, there are the number of vectors in these regions are is lower than what we have here. So in these cases, the vertex sampling it can, is better, I think. Then, you know, let me explain these settings. You can increase the reduction factor. Reduction factor is now equal to 1. So it means we have a velocity vector at each node, at each vertex of the grid. If you increase it to 4 or 5, then you will have a velocity vector. The number of the vectors is lower than what we had in previous view, because now we have one vector for every 4 vertex. Uh, you can change this, but I think it's not working for this case. You can change it to maximum number of points. Now you can specify the number of vectors that you want, but as I mentioned, it's not good for this case. Uh, maybe if I should increase it to 5,000, but it's not good for this case. The next option can be face center. Uh, Face center. Now the vectors are at face center. So you have a grid, and this is a 2D case. So each cell has 3 or 4 faces. It depends on the type of the grid. I mean the triangles or the quad grid, the quad meshes. So now the vectors will be released at face centers. And now here you can reduce the number using reduction factor. What is the next option? The next option is a rectangular grid. This one, uh, it can be used in some special, cases. Let's see the result. Here you can see we have a very bad view because the spacing is too much. Uh, let's decrease the spacing. I think I reduced it too much. See, this is the result. This way, we can have a uniform view of the vectors. But I think the best option for us is the vertex mode, and then where we can manipulate the size of the vectors. If you go to symbol tab, you can change the symbol. We have some options, line arrow, which is this one, which is the best one, I think. And also we have other options, for example, 2D arrow, 3D arrow, arrowhead. But I think line arrow is good for us. For example, you can show the vectors using this option by ball symbols. But here, this is the most important, I think, parameter. The symbol size, you can decrease it. And now you can see you have a good view of your vectors. And now, if we reduce the number, you can see here we have even we can get even better view for our vectors. You can play with these settings. Equally spaced can be good. The random is not good, I think. But vertex and equally spaced can be used in many cases. And also you can create an ISO clip. I think you can create an ISO clip around the cylinder, and you can show the vectors only on that ISO clip. You can change the coloring if you don't want to see the vectors in this color, which is the velocity. You can change it to another variable, or you can change it to a constant color, for example, black color. These are the vectors, and you can add, mm, for example, velocity contour in the background. It's easy. You can just show symmetry 1 and change the coloring to, for example, velocity. Now you have both velocity vectors and the velocity contour. You can change it the vectors to equally spaced and increase the numbers. Okay, let me create an ISO clip on symmetry 1. You know how it works. So I should select X, and X is lower than, for example, 5 meters. I need another uh, value for X greater than -5 meter, and also for Y greater than -5. And you can change these values, as you know. Let us check the ISO clip view. So you have to deselect the contours. So I think we have to extend the ISO clip in X direction. So I change it to 10, even 15. Okay, I think now it's good. So now we can change the location of the vector from symmetry 1 to ISO clip. Now you can see the result, and now equally spaced can be used, and we can change the color mode of the ISO clip to velocity. Uh, so you see how it works? Yeah, there is no other point that I want to say. Let's jump to the 3D simulation. You can see this is the inlet, this is the outlet, and here we have a symmetry plane. So the air comes in from the inlet and goes out from the outlet. Here we have some heat sinks, and we have to, let's say, we want to see velocity vectors. By clicking on this icon, you can create a velocity vector. And this is the three-dimensional domain. So you have to pick a location for, the view for viewing the velocity vectors. This is where we should use ISO surfaces. Or in this special example, since I have the symmetry plane, I can show the vectors on symmetry plane, on symmetry surface. We can't show velocity vectors on walls. It's obvious because mostly we have uh, no slip walls. Uh, let's choose symmetry. So this is our view. These are the velocity vectors. You can see here we have some vortices behind the uh, heatsink. And in three-dimensional, domains, you need to create a surface uh, and then create and generate velocity vectors on that. That's why I told you in the previous section, I think, isoclip and isosurfaces are the most important, locations that you can generate. So here, for example, if we want to see the vectors on a plane normal to y, we can simply create an isosurface. I should change it to y, and for example, on this plane, I want to see the velocity vector. So I will create a new vector and I choose the ISO surface 1 as the location, and let's see what we have. You can deselect the ISO surface. This way you can only uh, see the velocity vectors. You can change the symbols. I think if we reduce the size of them, we will get a better view, and of also for the previous vectors that we have. You can see the flow field using these vectors. Wow, it's fantastic. You can see the flow developing towards the outlet. What else we can do? We can change the color, change the coloring. So I can choose black for the coloring and for this one. And I can add velocity contour to the background. Velocity. Now you can have vectors and the contour at the same time. So I think that's okay, and we can end this session. This is all I wanted to show you regarding velocity vectors. You know how you can modify the legend, and you saw that in two-dimensional and three-dimensional domains how we should create velocity vectors. I hope this video is useful for you, and please don't forget to subscribe to the channel, to share these videos with your friends, and if you have any question, you can contact us using my contact info. You can find them in the channel description, and also you can um, ask your questions or problems in the comment section below. In the next video, we will talk about streamlines in two-dimensional and three-dimensional domains. So until the next video, take care of yourselves, and thanks for watching the video. Bye bye.